Hi everyone, and welcome to Education with Eleanor. Today we are going to learn how to calculate the gravitational field strength of an object. Usually it's a planet, and if we think about a planet, then it's usually so big that it's actually pulling, its gravitation is attracting everything to it, and so you can see here that all of the lines are going towards the center of mass of this given planet. And the other thing that we should look at is, see the dotted lines? They are fields, they are the field lines of equal strength. Now, what we want to know is that a field is a physical quantity that has a value at each point in space. Now, what we need to understand is that from the center of the planet, let's use a different color, from the center of the planet here, as we move out from the center of the planet and we say we get to this point in the field, it will have a certain field strength. And then as we get further away, that field strength actually decreases. And it decreases by the distance from the center of the object squared. So that's a very important relationship that we'll explore further as we learn physics, but it's something I just wanted to highlight right now. We're actually looking at Mars today, and Mars has a mass of 6.42 times 10 to the positive 23 kilograms, and its radius, or equatorial radius that we found, is 3.39 times 10 to the positive 6. So if we think about Mars, okay, and we're on the surface of Mars here, then we can use this equatorial radius. And that can be the distance from the center of the object. In this case, it's Mars. So let's calculate the gravitational field strength at the surface of Mars. So little g is equal to the gravitational constant multiplied by the mass of Mars divided by the distance from the center of Mars squared. So let's substitute that information in. So the gravitational constant is 6.67 times 10 to the negative 11 newtons meters squared per kilogram squared. And then we multiply it by the mass of Mars, which is 6.42 times 10 to the positive 23 kilograms. And then we divide it by the distance from the center of Mars, which is 3.39 times 10 to the positive 6, and that'll be in meters, and that is all squared. Our answer will become 3.73 newtons per kilogram. Now you're probably wondering, how did you get those units? Let's have a look here. Newtons meters squared times kilograms to the negative 2, and then we multiply it by another kilogram. In the denominator we have meters, and it's squared because we actually squared that distance. Now the meter squared in the numerator will also cancel out with the meter squared in the denominator. For our kilograms, we have a negative 2 here, and for this kilogram over here, it's a positive 1. So we've got negative 2 plus positive 1 because we're using our index laws. So that's how we're going to end up with kilograms to the negative 1, because negative 2 plus 1 is equal to negative 1. So that's how we end up with kilograms to the negative 1 there. And then the newtons itself, they had nothing to cancel out or change it. So that's why we've got newtons and then kilograms to the negative 1, and that's how we end up with our final units there. And our final answer is 3.73 newtons per kilogram. Alright, so today we've learnt about how to calculate the gravitational field strength. If you liked this video, press the thumbs up, and also press subscribe and hit the notification bell below so you get more videos on physics, mathematics and science. Bye!